Welcome back to class. In this session, we're going to look at the major themes in Chapter 11 of Daniel Jurgens' The Prize. And then I'm going to summarize for you, kind of in a broad way, his presentation in the next big block of chapters, which I did not assign on the syllabus. We'll pick up in the next class session with Chapter 20 and start discussing the settlement of the post-World War II international order. And so I want to sketch out for you some of the major themes in the chapters I did not assign to help you understand and pick up after we take this big jump in time. Uh, Assigning Chapter 11 here gives us a chance to check back in with sort of domestic, internal American history one more time before we get to this momentous change that is brought about by World War II. The other great thing about Chapter 11 is that it contains sort of in miniature within the confines of a single chapter the story of the larger cycle that Jurgen is trying to describe to us. That is to say, Chapter 11 opens with a kind of oil panic, that is a sense of the scarcity of oil. We're running out of oil because of the mass consumption during World War I. And by the end of the chapter, the world is again awash, a glut of oil because of new discoveries at the end of the decade. And Jurgen is going to try to describe to you the way markets adapt, new product innovations, and also the political response. And in that narrative, he's trying to tell you in miniature the broader kind of story cycle of the text as a whole. The two price charts that you see on the screen illustrate this price cycle, right? So right about 1911, with the outbreak of the war, the demand for oil increased exponentially. If you think back our discussion of the major regions, production regions in the world, even though the British do have the two other, two of the three international sources of production, let us say in Persia and in the Dutch East Indies, Texas remains by far the largest production region in the world. And so when the war breaks out, the British and the French, there's a lot of politics around this because the Germans would like to buy American oil too. And the process of the Americans choosing to provide oil only to Britain and France, that is to say the kind of democratic allies, was critical to the politics of America entering the war on the side that it did. You may be more familiar with that story as it regards munitions and sort of military assistance, which was the primary focus point of kind of media coverage during the time, but the discussion of oil was equally important. So with this dramatic increase in demand on oil, oil prices increased dramatically. And that's even in the face of the attempt by the federal government to impose price controls on oil. And that primarily successful as it regarded kind of industrial diesel oil, because they would make federal contracts and allot them to different industrial sectors through those war industry boards. So say the steel mill industry needed to turn out so many tons of steel under orders by the federal government. The federal government would require Standard Oil or Texaco or any one of those companies to deliver to the various factories in the steel industry enough diesel oil for them to achieve the production quotas that they were assigned. This is what we were talking about in the last class session regarding federal regulation of the economy in a far more dramatic fashion than had ever happened before. So even in the face of the federal government trying to impose price controls, the price dramatically rises. And if you look on the lower left-hand graph, which attempts to sort of the actual prices are in the background, that's the shaded portion. What it's really trying to measure is the stability of oil. And what you notice there in that lower graph, right as World War I breaks out, there's not only a price rise, which is substantial, but there's a dramatic increase in the instability of prices, right? That's the key thing, that the prices become highly erratic. And Jurgen opens chapter 11 by describing the sense within the American economy and business culture that World War I had effectively exhausted the known oil reserves in America, right? That we had sort of spent our great resource saving Britain and France from the Eastern powers, if you will, but now we were left without oil, and in the face of rising automobile use and production. The expansion of the internal combustion automobile, if you think about it in all of its different configurations, from the family car to the delivery truck to the tractor and other kind of agricultural implements, really is one of the great stories or themes of America in the 1920s. For the first time, cars become accessible, if you will, to middle class, working class people. You see the advertisement in the middle of the screen, famously the Ford Model T for around $500. This advertisement says $580, but I suspect that the Tudor is some kind of premium trim options on that Model T. And the theme of the advertisement in the upper right hand corner, everyone owns a car but us, right? So this really is the first mass consumer culture around direct gasoline consumption, right? The object that becomes the marker of middle class status in America. The various electrical inventions, right? Electric lights and electric fans and whatnot, really is not accessible to most people. You have to live in a big city for the most part, and you have to be pretty wealthy in that big city to have residential electricity. And so the automobile, again, in all of its different configurations, becomes the emblem of the oil age in America in the 1920s. Being able to sell automobiles to working class consumers at a price that they can afford required a revolution in production methods. You are likely familiar with the story of Henry Ford and the production line facilities really invented and innovated here in the Metro Detroit region. And the images that you see on your screen are all images from local Detroit factories. You may recognize some of them. Prior to World War I, most automobiles would have been produced in kind of artisanal shops, right, with the handcrafting of each part. What Henry Ford does really is adapt the production methods that were created during World War I, particularly for munitions productions, right? The factories that produced artillery shells and the way they moved the shells down conveyor belts, and the workers applied their particular task as the shells moved down, and produced on a far greater scale. That is to say, you have to imagine not just the workers in these plants applying the wheels and tightening the lug nuts. This also requires the shipments of the parts, both the raw iron down to the River Rouge plant, its processing into rolled steel and whatnot, and the delivery of those I-beams and the frames from different factory facilities around Metro Detroit, which you're very likely familiar with. So it was a kind of mass campus, if you will, or a whole region filled with campuses that had to have railroad tracks and canals connecting them. If you're familiar with the topography of Metro Detroit, we're living in kind of the built environment of the 1920s and the 1930s. This truly was a revolution in industrial production. You have to look at these images on your screen and think, this is the most advanced, technologically advanced production facility in the world. Not that different than kind of a, Taiwanese or a South Korean microchip facility today, right? The technology being applied here is futuristic, if you will, and the ability of these factories to churn out hundreds of cars per day is really unmatched anywhere else in the world. And you can see the impact of that in the chart in the top right hand corner of your screen, which shows automobile ownership per automobile stocks, at least per 1,000 people. The blue line at the top of the chart is the U.S. ratio. So it's going to start, it's going to peak in about 1928 at just over 120, maybe 140 cars per 1,000 people in the United States. The three red lines are a little more difficult to read. The long dash, red line, is the average of the rest of the world. That's what the ROW in the legend means, the rest of the world. So, but you have to imagine outside of the United States, there's a dramatic difference between sort of Western Europe and Northern Europe, the industrialized, the most industrialized part of the world outside of the United States, and then the entire rest of the planet, most of which is living in a pre-industrial production state, right? The colonization of the rest of the world, it's generally only in the colonial capitals and outposts and sort of military bases where you have European, advanced European technology. So if you try to separate that out and you look at the two dotted red lines, that top red line that's very close to the blue line, the United States, is essentially Western and Northern Europe, and the bottom dotted line is the entire rest of the planet outside of the United States and Western and Northern Europe. And if you think about automobiles not simply as the family sedan, but all the different platforms of the automobile, trucks, delivery trucks, and especially agricultural equipment, you see here just how dramatically in the 1920s the advanced industrial countries separated themselves and started on a distinct sort of productive path, or production path, if you will. There really is a cleavage here in the aftermath of World War I between the state of technology broadly in the Western world and the entire rest of the planet. All of those new cars, of course, are going to need roads to drive on. Or, more accurately, there needs to be a dramatic improvement in the road structure of existing roads. Jurgen begins chapter 11 by telling the famous story of Dwight D. Eisenhower's 1919 cross-country drive as part of a military convoy, and that anecdote is so famous because, as we'll learn in later chapters, when he becomes president after World War II, it's the same Dwight D. Eisenhower who is going to advocate for and finally sign the 1956 National Highway Act, which will create our modern interstate freeway system. It's significant that he is I'm not sure if he's a colonel, maybe he's a general in the post-World War I period, but that there is this military justification for the building of a cross-continental transportation system. Eisenhower is going to use the same rationale, military necessity and national security, in the 1950s to argue for the necessity of an interstate freeway system. The first stage of that transition is going to happen here in the 1920s. And while the two maps that are on your screen illustrate the state of roads in 1907 and then again in 1928, they really, of course, exaggerate the contrast because all through the 19th century, there are endless paths and wagon routes and horse trails and varying degrees. They just are very seldom structured as formal public venues or avenues for transportation. Where there are major turnpikes and canals and bridges are enormous infrastructure projects in the 19th century. They are overwhelmingly built and maintained by private companies. That's really the significance of the railroads being built by private companies. They are so emblematic of the 19th century. One of the profound changes here in the early 20th century, the map that you see in 1928, what it really represents is those endless wagon trails and footpaths and horse trails and whatnot, the local municipalities or the state governments taking responsibility to improve those things to a condition where automobiles can drive down them. Now, The more rural or remote or kind of more primitive the path, it might be improved to where traffic can move 15, 20, 25 miles an hour, right? You're still talking about rutted, uneven, even gravel-paced roads, though of course there are going to be building modern, at least asphalt roads in this period. What we're really talking about is improving all the existing modes or kind of routes of transportation to the condition in which they can sustain automobile traffic. There's nothing like four-lane modern interstates in this period, and what that really signals is a dramatic new role for government to fund the infrastructure for transportation. These routes are becoming so important for the transportation of goods and supplies that the local municipalities in places like Chicago and Cincinnati and Philadelphia and Boston and New York and St. Louis and Kansas City, places right in Detroit, it is so vital to the local economy to be able to bring in truckloads of goods, either raw materials to feed the factories or to take away boxes of the finished products, that government has to become involved. The amount of capital needed, the amount of resources needed to build this road system is just astronomically beyond the ability of any private company, and it would dramatically hinder commerce if you had all these roads owned by private companies charging tolls, right? That's the consequence of companies owning things. If you let a private company build the bridge, then they're going to put a toll gate on that bridge and charge people that want to walk across it to get a return on their investment. So the really dramatic, there's an exponential increase, if you want, in the mileage of roads that can sustain automobile traffic. Even the best roads you can't drive faster than maybe 40, 45, 50 miles an hour on, but to build the more primitive kind of trails and paths up to the level of roads. And then the second important thing is an increasing role for government funding, which of course necessitates taxation and all the rest. This theme of an increasing role for government in sustaining the oil economy infrastructure then is a nice transition to one of the other anecdotes that Jurgen relates in Chapter 11, the story of the Teapot Dome scandal. Now, this was a kind of generic, your typical corrupt politician payoff kind of scandal. You have this president or CEO of Sinclair Oils named E.L. Doheny, and he's going to give a bribe to the Secretary of the Interior, Albert Fall, in the awarding of a federal contract over an oil reserve discovered in eastern Montana known as the Teapot Dome. But the nature of the contract and why the federal government is in the business of doing this, awarding this contract, doesn't make a lot of sense if you don't understand the kind of national security theory in the aftermath of World War I that was sort of decided upon or studied and concluded by, if you remember, the National Petroleum War Services Board, that war industry board that was put in charge of oil reserves. Jurgen refers to this as conservation theory, and he's going to refer to it a couple more times. It really is the dominant way of thinking in national security terms by the federal government, really up until the 1970s and the oil embargo and the kind of the revolt of the producers that we'll talk about later in the class. The idea of conservation theory, and it's tricky because it uses that word conservation in almost the opposite way that we're accustomed to using it today. Generally today, when we use that word conservation, we mean using less energy, right? Conserving, using more efficiency or developing greater efficiency with the oil that we consume. That's not exactly what they meant as a national security idea. The idea of conservation is we should conserve American resources. We should leave the oil reserves that we find within the United States, kind of territorial boundaries. We should not pump it out of the ground. Rather, we should go around and help develop all the oil reserves we can find in every other country and region of the planet. We should use up, that is to say, we should buy all of that foreign oil first, and when the rest of the world's oil reserves are completely exhausted, we, the United States, will be sitting on the last great deposits of oil left in the world, and that will make us not only economically self-sufficient, but it will make us the greatest military power in the world, because of course the conclusion of most military planners at the end of World War I is when the next big war comes, whoever has the most oil will win. So conservation theory, as it's used especially by kind of military planners, national security theorists, all the way through this period and up until the modern period, means something very different than the way we use that word conservation today. So that's the point of the discovery of the Teapot Dome Reserve and the federal government, that's out in federal lands out in the West, the federal government exerting its national security authority over that big patch of land and saying, we are not going to pump this oil. Right? Now, that leads to the strangeness of this contract. Sinclair Oil, they get a sweetheart deal because they bribed the Secretary of Interior, but nevertheless, Sinclair Oil is paying its fee for its license for permission not to drill, which is sort of paradoxical. Now, of course, they're going to get to sit on this, and whenever the federal government says, we need that oil, it's time for our national security to pump that oil, Sinclair Oil then will be the company sitting on one of the last great oil reserves left in America. That whole way of thinking about the federal role in overseeing the national oil reserves is, of course, radically different than you've probably heard about it discussed in our current day politics. That is to say, drill, baby, drill. American energy independence. We don't want to import any foreign oil because we don't want to be giving American dollars to competing countries, and especially to countries that are sort of our rivals in the world, when we have to give money to our enemies, if you will, in geopolitical terms, that undermines American national security. So we should try our best to rely only on American oil. That's a much more typical way for you to have heard this discourse in our contemporary society. And of course, Jurgen's point is to show you how there is this cycle that over the course of time, over this century and a half, 175 years that we've been dealing with these issues, American politics, the political system, has taken different positions at different points in time. Within the story of Chapter 11, that is this cycle of oil scarcity, or the perception of oil scarcity at the beginning of the decade, and moving towards an oil glut, right? An excess of oil by the end of the decade. You're going to want you to sort of take away from this story, whenever the government gets involved, they inevitably screw it up, right? There's always dirty politicians and ultra-rich oil company executives that make corrupt backroom deals. And as we turn now to the other examples that he wants to talk about, the other subjects that he wants to talk about in this chapter, you'll get the sense that if the government would just keep its dirty nose out of this oil business, science and the evolution of free markets will solve the problem of scarcity. So he tells you this story of the Teapot Dome scandal here, sort of as the second step in the chapter, to then turn in the remaining of the chapter to talk about the forces that are going to solve the problem of scarcity. Jurgen describes then a series of technological and scientific innovations that are going to help in the search for new sources of oil and bring about an end to the period of scarcity. Some of these innovations have a kind of long backstory, and that's certainly true in his explanation of the development of refraction seismography. This science depends on an invention or an instrument that was developed in the late 18th century, Coulomb's torsion balance. And the essential thing that the torsion balance does is it uses the resistance between magnets. If you look at the diagram or sketch in the top right-hand corner of your screen, the green dot and the red dot are essentially charged magnets, right? They're charged spheres. They hang in the air at in resistance to each other, and then even the slightest vibration will cause those magnets to move closer together and farther apart, right, on a very small scale. And what you see there is an instrument that allows us to view this tiny microscopic changes in the distances between the magnets. Now, this has been around, as I say, since the late 18th century, but it's largely a laboratory instrument, right? It's a very finely calibrated and delicate instrument. The real innovation in the late 19 teens into the 1920s is to develop a kind of field version of this, right? To be able to make it rugged enough and versatile and what do you want to say, mobile enough that it can be carried out into the field to do experiments. That essential instrument, the torsion balance, is at the heart of is kind of the central instrument that's built into the seismograph, which you see on the top left-hand side of your screen. Hopefully you are familiar with the seismograph, right? This is how we measure earthquakes and kind of tectonic movements. Notice that the string in that figure is being suspended between a magnet there, and that's a sort of a cartoonish version to illustrate for you that same principle that's in the torsion balance. Well, the science that is developed in the 1920s, and again, we've had the seismograph for at least decades before the 1920s, but the real science that is developed in the post-World War I period is how to create seismic waves, essentially blowing up explosion, lighting off a couple sticks of TNT, or the equivalent, on the surface, and then using the seismograph to measure the distribution of those vibration waves, right? So they're going to start out huge, and as they penetrate deeper, the time that it takes them to reflect back to the surface so that you can measure them with your seismograph, that time is going to vary depending on the composition of the layers beneath the earth, the subterranean layers. So it takes some decades to kind of figure out what the different kind of mineral layers, how they respond to distributing vibration. But refraction seismography then is a kind of first attempt to take an X-ray, if you will, of the layers of the earth beneath the surface. And it's going to, as the science progresses and gets better and better, it's going to allow for very, very sophisticated underground mapping, as you see in the image on the lower left hand of your screen, which is a kind of cross section of the subterranean layers of the continent of Europe. Geologists have never before had a way of, if you will, kind of mapping those underground layers without being required to actually dig them open and look at their composition and view them visually, if you will, or physically in your hands. For the first time, we've got a kind of X-ray machine that allows us to see the underground layers of the earth. This is going to be a fantastic improvement in the science of geology, and not just for oil, though it is the oil companies that develop this technology, but for all kinds of minerals to start hunting for them. And this is a profound technological change that develops in the 1920s, or comes to, if you will, kind of practical application in the post-World War I period. A second major technological breakthrough after World War I occurs in the process of refining oil, what Jürgen refers to as oil cracking. The basic refining process remains the same. We're simply heating up the oil and removing the different compounds that are released as the original heavy crude oil or tar raises in temperature. Different compounds are released from the top. That same basic idea continues, but now we're going to learn a couple of new processes. The most important is we're going to start doing this under pressure, right? And the addition of doing it in a closed container under pressure is going to allow us to control much more closely or much more stringently the chemical processes being released. And the second thing is we're going to start recirculating. So we skim off one product and we send it back through the system to be refined yet again. That requires major changes, if you will, in the kind of the infrastructure of the refining facility to be able to accommodate especially the pressure, doing this under pressure, and also also the recirculation. But we're going to make two key breakthroughs in the chemistry of oil refinement. The first has to do with recognizing that the hydrocarbons that we are searching for are come, if they will, as they're refined and released to the surface in long hydrocarbon chains. And if you've taken basic chemistry, you should be familiar with that idea of a hydrocarbon chain. And essentially what we're going to learn to be able to do is kind of snip those chains into finer and finer, shorter and shorter lengths, which is going to allow us to release all of those minerals that we don't want, all of that sulfur, all that mercury, all the other junk that is mixed up with the hydrocarbon chain in the original tar or crude oil state. By snipping these long chains, not only are you making them shorter, but you're making the other associated minerals or elements less stable and easier to break apart. The end result of learning how to crack these hydrocarbon chains is a doubling of the productivity per barrel of oil. That is to say, once we learn cracking, we're going to be able to derive roughly double the number of gallons of gasoline per barrel of oil than we were previously. A closely associated breakthrough with that, it really comes down to having a much more sophisticated understanding of the chemistry, is that we're finally able to recognize octane number and isolate and manipulate the octane number. Hopefully you're familiar with that's sort of the concentration or the potency of the hydrocarbon chains, and the key to raising the octane number, think of cracking as snipping those long chains. The octane number comes with branching those hydrocarbons. So if a chain is a long narrow thread, branching then is to create kind of lateral, if you will, molecular structures. And of course, higher octane gas is much more efficient because the internal combustion engine is not processing all of that junk, all that mercury and sulfur and all the other nasty stuff that's not helpful in burning, right? It doesn't release energy. It just kind of gums up the engine. Higher octane fuel is essential to the development of airplane technology and aviation. Airplanes, especially propeller-driven planes, but also you may be familiar, airports have to order distinct jet fuel. The fuel that goes in our modern jets is not the same as the gasoline that goes in our cars, and it's the Americans, chemists, who are going to make this discovery, and this will become a critical advantage for the Allied forces when World War II comes around. We have great pride in our American engineered and developed planes from this period, and we have a strong sense that the American planes, the Mustang and the Corsair and the other famous planes of the World War II era, were superior because of their American engineering. And indeed, they were every bit the equal of the German or the Japanese planes, but one of the real decisive advantages that American pilots had is they were running their planes on 100 octane fuel, and the Germans and especially the Japanese were running on that standard old 84 octane like you put in your own car, and that provided the American pilots and the Allied pilots with a decisive power advantage when they were up there dogfighting with each other in the skies of the South Pacific and whatnot. So these two breakthroughs in the chemistry of hydrocarbons, being able to break up the long chains and then be able to force those molecules to branch out laterally, are both key scientific discoveries that really come to a practical application stage in the decade or so after World War I. A third innovation described by Jürgen in Chapter 11 is unitization. And this is not so much a technological breakthrough, though it will require the development of new types of wellheads, as you see in the image in the lower right, but more an innovation in the scientific understanding of the, if you will, the physics of an oil field, the internal dynamics of an oil field, and the tremendously wasteful methods that oil companies have been using up till now to extract oil from under the ground. If you go back to our discussion of the dilemma of overproduction and that that principle of law, the rule of capture, which was a principle of American property law or mineral law. And if you recall, the rule of capture said if there are two landowners and their land boundaries abut each other, and there's a common pool of oil or any mineral resource beneath the surface, both landowners can take as much of that common pool of oil as they are able to, as long as they only disrupt the land at the surface on their side of the land boundary. And if you recall our discussion, that gives both landowners tremendous incentive to put as many oil wells on their surface land as they possibly can, stick as many holes in the ground as they can, and suck up as much of that common pool of oil, because if they don't, their neighbor is going to do exactly that and take the oil from them. Now, if you think about the geologic structure of a typical oil pool, remember it exists underground under pressure, that it's releasing water and gas as well as oil, and especially that gas is trying to expand, and that creates pressure. So think about a kind of a can of whipped cream topping that you might buy at the grocery store, right? It's held in that can under aerosol pressure, and when you open the nozzle, it's that gas in the can that forces the whipped topping out. Well, if you were to poke that can with a bunch of little pinholes, those pinholes would let all the gas out, and now that whipped topping would be trapped down in the can, right? You'd get less of the whipped topping out of the can if you let the gas out without forcing the whipped topping out with it. That's essentially what the rule of capture encourages for mining operations, right? You're sticking hundreds or even thousands of straws down into that oil bubble, and the more straws you poke in there, the more gas that you're letting get released, and that's going to leave oil remaining down in the reserve underground. Henry Doherty, who is an oil man executive, but is also the first person that's credited with making this realization about the truly awful, horrible, inefficient methods that American companies have been using to drill, to have this insight that if we could control the release of gases, that's the key to unitized development, is we're going to force the landowners to have fewer wells and to space them out more evenly. And then we're going to connect all the different oil wells, the kind of penetrations of the surface, into one common pipeline network into this new form of wellhead you see in the lower red. This is called a Christmas tree wellhead. And the key thing, you see all those valve wheels or those valve dials on the wellhead. What that allows you to do is turn on and off different sections of the field as the pressure rises or lowers. So it allows you to even out the gas pressure across the field. You're going to have fewer total pinholes in the field, and then you're going to shut off and release different sections of the field. So if you have excess gas in one section or it's being depleted in another, you can essentially divert the gases. The gases will even themselves out underground. This technology is going to allow oil companies to go back to those early fields that they thought were depleted, right? That the gushers had run dry. Use this new unitized method of development, capture the last little bit of gas that's remaining in those fields, and if you will, kind of redirect it. This is really the root insight that's at the base of modern fracking, right? With modern fracking, we're simply taking big fire hoses full of fluid, we're pumping them down underground to create pressure to force the remaining oil out of all the different cracks and crevices that is pooled up and remained underground. We use fracking fluid to create pressure to force that oil out of the ground. That's going to take another 70, 80 years for us to develop that technology. Unitization is the foundational kind of scientific insight. Now, we credit it to Henry Doherty. Jurgen's going to tell you the story. He gets appointed the chairman of the Federal Oil Conservation Board, and there's going to be a series of hearings. So this is yet again another example of government regulation. By the end of the day, the federal government is going to have a smaller role to play in this for at least the first half century or so, but it'll be state level conservation boards and especially regional boards that are going to go throughout the United States and impose rules on landowners. Yes, that's your piece of land, but you cannot just go set up oil wells anywhere you want to and exhaust the field. You have to follow the especially state regulations that say you have to cooperate with all the other landowners in the area and come up with a common unitized field. So here is an example from Jurgen of government regulation in a positive light, right? As you read Jurgen's description here, you get the sense of, oh, those, corrupt independent oil companies that won't get on board with this new regulation because it's smart and it supports scientific development and a more efficient extraction of the resource we're looking for. So this is a kind of opposite example to the Teapot Dome scandal, where you have corrupt politicians making dirty backroom deals with oil executives. Here you have a form of government regulation that is trying to sustain the oil industry. These technological innovations are going to come together over the 1920s and by the end of the decade lead to major new discoveries of oil reserves. It's going to allow oil company explorers to go back to existing fields that they thought were depleted and renew them and produce greater productivity out of them. But also, particularly the development of refraction seismography is going to lead to the discovery of major new fields. It's going to open up West Texas and West Oklahoma. And in California, prospectors are going to look just on the kind of north slope of those mountains that ring Los Angeles, the southern end of the central Sacramento Valley, and discover huge new deposits of oil in what is today really the center of the Californian oil industry, but not just in the United States. For the first time, these Latin American countries, Mexico and Venezuela, which do have kind of crude, primitive oil industries before World War I, that these new scientific tools are going to allow geologists to discover the major deposits in Mexico and Venezuela that are going to elevate these countries as major oil producers, major players in the world market. Jurgen, and hence us following Jurgen, are going to primarily focus on those Middle Eastern countries because it's that Middle East region that really drives the geopolitics of the 1950s, 60s, and 70s that we're going to look at in the next section of the class. We're going to spend relatively less time on the Latin American countries, but Latin America, what's in some places referred to as Caribbean oil. If you think of the East Coast littoral that surrounds the Caribbean Sea, and think of Mexico and Venezuela and the American Gulf states as representing kind of that archipelago or that shoreline around the Caribbean Sea and all the oil that we have discovered there. So sometimes that American Gulf Coast oil, Mexican oil, and Venezuelan oil is all combined together and described as Caribbean oil. We'll see that further along in the course. And as we just discussed in the last class session, the Red Line Agreement is formalized in 1928. There are plenty of European oil explorers over the course of the 1920s as that treaty is being negotiated, as those agreements are being negotiated, and it's after the Red Line Agreement is signed that the first kind of Arab concession reserves, now not Saudi Arabia, not the Gulf states as we'll see, primarily that area of northern Iraq around Mosul and Kirkuk. The geologists have been in there for a few years by the end of the 20s, and those first major huge Middle Eastern deposits are being discovered right at the end of the century. So if you look at the chart on the bottom left hand side of your screen, the green line represents crude oil discoveries, and the gold or yellow line at the base represents actual production. So of course it takes years after discoveries are made for production to come online, but what you see there right at the end of the 1920s transitioning into the 1930s is that first this giant jump up in the green line, that giant spike. And you'll see over the next 30 to 40 years, we're going to have a succession of those giant spikes. But the first one comes here right around 1930, and it's the result of these technological innovations. And then you can see in the upper right-hand chart what happens to price. From the peak spike around 1920, you see that price spike up. By 1931, combined with the Great Depression, which is going to lower consumption, right? As the economy slows down because it's in depression, factories aren't running as many hours, there are fewer trucks on the streets transporting goods. That dramatically reduces the consumption demand on oil supplies. So you have at the very same time enormous, sort of astronomical quantities of oil, unlike we've ever discovered before, all coming on the market in the same couple of years at the very moment that the economy is consuming dramatically less oil. And so by 1931, oil is trading at less than $1 a barrel. That is less than the cost of producing the barrel of oil. It's an unsustainable market, primarily driven, of course, by the Great Depression. The point that Jurgen is trying to make to you, and you can agree with Jurgen or not agree with him, you can sympathize with his view or not sympathize with it, is notice how the market corrected itself between 1920 and 1930. There was all this kind of hair on fire panic among people about us running out of oil, but if you let science like technology and you let the market work out a solution for it, within 10 years you're going to have oil so cheap that the oil companies can't stay in business. That this is a recurring cycle in the American oil industry. And one of the nice things about assigning you Chapter 11 is it gives you a chance to see that complete cycle all within one neat chapter, one neat decade focused on the same kind of topic matters to take you through the narrative. So the problem becomes, by the beginning of the 1930s, not how can we find enough oil, how can we produce enough oil, but how can we sit on this oil and not bring it to market to limit the supply so that we can drive the price up to at least a sustainable level, right? A complete story cycle. Now we're going to skip the next big block of chapters. The next 8 chapters are not assigned on the syllabus. We'll pick up in the next class session with Chapter 20. The major event described in the chapters that I did not assign, of course, is World War II. And because the next chapters really depend on at least a kind of basic understanding and familiarity with the major themes of World War II, I'd like to spend just the last few minutes of this class session summarizing those chapters and identifying a couple of the most important themes that you'll need to at least be familiar with for the next set of reading assignments to make sense for you. So if you're at all curious or interested in the history of World War II, or you've done any kind of studying, or there's certainly plenty of media and documentaries available on it. Jurgen does not try to tell the entire story of all the events of World War II. He tells the story of World War II from the perspective of the competition and the race for oil reserves. He tells World War II from the perspective of whoever is able to access and control the most oil resources is going to determine the victors of the war. And if you're at all familiar with kind of the literature and the media around World War II history, you'll understand that this is not an uncommon or unusual perspective. The major Axis powers in Europe under Nazi Germany and the Italian fascist regime, and also the Japanese and the South Pacific, both face critical resource challenges at the outbreak of the war. Germany and Northern Europe have enormous coal reserves, and in the age of coal power, Germany is a great industrial power, but they have very limited oil resources. And so one of the great questions in the strategy of World War II is, why did Hitler, after he conquered Western Europe, why did he turn and open a second front by invading Russia? This is kind of the classic error of Middle European nations and empires going back 1,000 years. years. You can't fight a two-front war, and this is always kind of one of the great questions about German strategy. Why did they open that second front? Well, if you look at the map in the lower left-hand side of the screen, you see the red on the map describes the furthest extent of German advance. In particular, to the east there, you see those two black arrows leading to the Caucasus Mountains, and then the second arrow leading to Baku. If you go just a little bit north, kind of the northwestern shore of the Caspian Sea, that's that furthest extent of the German advance. And the critical site there is the city of Stalingrad, right? The Battle of Stalingrad was the great determinative battle of the war. The city of Stalingrad is the last major town on the Volga River that extends all the way up from nearby Moscow and empties down in the Caspian Sea. The Germans were desperate to capture Stalingrad so that they could essentially secure their northern flank for their attempt to go in and seize the oil fields of Baku. The oil resources that we've already discussed around Baku were the critical geostrategic objectives of the German advance. When they were defeated at Stalingrad and the Russians counterattack, because they don't have enough oil, Germany's going to face critical oil shortages all through the remainder of the war. And you can see a similar thing in the lower right-hand map of the Japanese kind of geostrategic map. Japan has even fewer mineral resources. The home islands of Japan have even fewer mineral resources than Germany, of course. So starting in the early 1930s, the Japanese are starting to colonize northwest China, a region known as Manchuria, and the southernmost kind of appendage of Manchuria is the peninsula of Korea, which hopefully you're familiar with. Tons of iron and copper and tin and other minerals in the mountains of Manchuria, but not necessarily a great deal of oil resources. And so the Japanese critical objective is to seize the oil of the Dutch East Indies, the region that will become Indonesia that we've already discussed in the previous class session. So the attack on Pearl Harbor out in the middle of the Pacific, that's the great American naval base in the middle of the Pacific. The attack on Pearl Harbor is designed similarly to the attack on Stalingrad, though it's more successful and not completely successful, to protect the Japanese western flank so they can go in and seize those islands of the South Pacific with the great objective of seizing the oil resources of the Dutch East Indies. And they are successful for that initially. Again, if you're at all familiar with the kind of military strategy of World War II in this region, you may have heard the term the island hopping strategy. And the U.S. Marines are going to go in essentially on the easternmost reaches of those South Pacific islands, the Solomon Islands, and they're just going to do a series of island invasions and some of the most brutal battles, brutal warfares of World War II. But again, the U.S. goal is to remove the Japanese from their hold on those oil production facilities in the Dutch East Indies. When the Americans succeed in successive battles, right? The Battle of Leyte Gulf, the Battle of Guadalcanal, you may have heard of some of these names. These are sort of the most famous battles of World War II in the South Pacific. When the Americans succeed in those battles and they remove the Japanese from their control of those oil regions, the Japanese fate is sort of doomed in the war. They're going to face a perpetual struggle with a shortage of oil, and it means that their planes are not going to be able to fly as much, their ships are not going to be able to go out as far, and they're going to have increasingly limited sort of military capacity until ultimately the Americans are able to roll up on the mainland of Japan itself. In both of these kind of grand geostrategic visions, then, it was access to oil that both drove military strategy and determined the final outcome. And you can see that dynamic play out in the data illustrated in the charts on the screen. If you start in the upper left-hand column corner, which illustrates the Japanese petroleum consumption, you see on the pie chart on the left-hand side where Japan got its fuel at the start of the war, and it was 70% dependent on American oil. That is Texas oil and California oil that you're seeing there. When the Japanese attack Pearl Harbor in 1941, the United States imposes an oil embargo on Japan, and it deprives them of 70% of their oil resources, and that's what makes that drive for capturing the South Pacific Islands so acutely important to the Japanese. If you look on the bottom of the screen there, which describes the German fuel consumption, Germany had a more diverse kind of portfolio of oil resources, but still fully one quarter, 25% of their oil before the war broke out was U.S. oil, and another 29% is described in this chart as Caribbean oil, which is really Mexican and Venezuelan oil, and both Mexico and Venezuela are heavily under the influence of American foreign policy because of the Monroe Doctrine in the Western Hemisphere has been traditionally an American, from the early 19th century, an American sphere of influence. So when the war breaks out, Germany is deprived of both American and Caribbean oil for the most part, and you see what happens to German fuel consumption in the bar chart on the right-hand side of that figure, similarly with the Japanese. The Japanese reach their peak in 1940 and just plummet thereafter. The Germans, because of their conquest of Eastern Europe, are able to, sort of replenish their supply at least through the middle of the war, but when they fail at Stalingrad, they fall off a cliff and they're not able to keep up with their fuel demands. You see in contrast then on the right-hand side of the screen in the middle, the U.S. oil consumption that right through the end of the war continued to increase. We maximized production of American oil, and we were not only able to maintain our industrial, kind of civilian industrial production to feed the war effort, we were also able to generate enough oil to fuel the machines of all of the Allied armies. In the lower left, then, you see a graph of Russia, and we don't get the same data to show us the progress over the war, but what it does show, that sort of 80% of the chart there, that solid gray, is Azerbaijan oil or Baku oil. And what that chart illustrates is just how dependent the Russians were on that one production region at Baku. World War II demonstrates unambiguously that the side with the most oil won. And this was a kind of prediction, an expectation in the aftermath of World War I. World War II demonstrates the lesson of that prediction clearly. So in the next section of the course, we're going to see American and British oil companies especially going out into the post-World War II world and trying to structure the post-war settlement, the political settlement in the aftermath of World War II in a way that secures their access to oil resources, because they understand their success in this endeavor is critical to their future security and safety. That effort, though, is going to come up against or combine with a couple of other very important consequences of World War II. Another is the final end of the 19th century imperial system. If you recall back to the last class session, our discussion of the end of World War I, there's a kind of recognition that the 19th century system should no longer prevail in Europe, right? Because all those Eastern European countries get to have their own nation states. But in the Middle East, and we didn't talk about other regions, but we think about Southeast Asia and Africa, there was this kind of pseudo quasi end of colonialism, that League of Nations mandate structure where, yes, these people were recognized and their autonomy and their kind of cultural integrity are recognized, but they were nevertheless put in tutelage and kind of a mentorship or apprenticeship relationship with one of the great European powers. powers, right? So there is still this legacy of colonialism that survives World War I. That kind of pseudo state, that kind of halfway state, is going to end after World War II and the creation of the United Nations. In the 1950s and the 1960s, and even extending into the 1970s, a kind of international geopolitical process of decolonization is going to pervade international relationships. That is, these places that had been colonies, some of them had gotten a kind of early start of nationhood after World War I. Some of them were still in this tutelage. Some of them were still straight out colonies. That whole system is going to end, and over the course of decades, the peoples of these regions are going to fight wars of liberation and resistance movements. If you know about the independence movement in India and in Iran, it's going to happen in state after state. Now, this is a global process, right? We're going to focus on the Middle East region in particular because that's Jürgen's focus, and it is the story of decolonization in North Africa and the Middle East that really drives the international politics of the 1950s and the 1960s. Each one of these countries has their own different, unique story. What the nature of their colonial relationship was, the kind of mix of ethnic groups that exist in this region. In some places, these boundaries follow kind of natural geographic lines or geological lines that have separated ethnicities for centuries or millennium. In other places, it's a kind of hodgepodge of groups that had thought of themselves as distinct and separate, but were kind of shoehorned together into this modern nation-state structure. So we're going to have to follow the kind of culture and politics of decolonization or the independence movements to understand the complexity of Western companies' attempts to come in and gain access to the oil resources in this region. And a second important sort of geopolitical outcome of World War II is the emerging rivalry between the United States and its Western allies and the Soviet Union and its Eastern Bloc allies, what we refer to as the Cold War. The Soviet Union, the United States, Britain, and France were all allies in World War II as they fought the Nazis and the fascists, but as they defeat the Nazi powers, the Axis powers, they're going to discover a great ideological rivalry, if you will, between communism on the one side and capitalism or democracy on the other. Now this and they're going to increasingly come to see the entire planet as being divided up between these two great powers. Now, this trend towards the Cold War is going to overlap in complicated ways with the culture of decolonization or national independence movements because, of course, if you are a person who lives in a place that was a colony in the 19th century, if you read Karl Marx or Vladimir Lenin or Mao Zedong, they're going to articulate for you a political ideology, a philosophy that is really going to help you understand why those Western European countries came into your region, your nation, dominated and subjugated your neighbors, and extracted mineral resources and other agricultural resources and took them back to Europe. That is to say, communism as a philosophy explains why capitalist countries are so imperialistic. So there's a kind of natural draw between left-wing socialist theory and these national independence movements. At the same time, there's all kinds of internal domestic cultural elements within these regions that makes them highly resistant to communist theory. If you think about the Middle East and the Arabic states being intensively Islamic, if you know anything about communist theory, it is aggressively anti-religious, right? Marx said that religion is the opium of the people, and the Soviets are notorious for going in and, sort of destroying churches and mosques and temples and making it prohibiting people from worshiping as they please. Well, there's going to be a strong antipathy between those countries and cultures that identify themselves as being Islamic and nevertheless them having an attraction to sort of Bolshevik or communist theory that explains to them why those dirty Europeans were such nasty imperialists all through the 19th century. So there's a complicated relationship between the political movement for national autonomy from colonial peoples and the rivalry between the United States and its allies and the Soviet Union and its allies over the same period. The United States is going to tend to see any criticism of these countries' relationship with the United States as a kind of proclivity towards communism, right? If they're not on board with our Western companies and the kinds of contracts that we expect them to sign, it must mean that they're communists, and it must mean that they're in league with the Soviet Union. The United States is going to tend to see these relationships in very black and white terms because their vision is so colored by the rivalry of the Cold War. Now, of course, just because you're paranoid doesn't mean that they're not out to get you. And in fact, there are sort of left-wing socialist tendencies and communist groups within these different nations. So we're going to want to follow this story in the next assigned chapters and understand the way in which these dynamics are really rooted in the experience of World War II. So let's leave it there, and we'll pick up with chapter 20 in the next class session.